Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi, I'm Dr. Rohana. In this video, I'm going to explain to you how to analyze clamper. Function of clamper is it will shift the waveform to a different level without changing the appearance of the original input signal. We're going to look later what is meant by that. Okay, another characteristic for the clamper is it must have this capacitor. Compared to the clipper, there's no capacitor. So that's how we're going to differentiate between the clamper and the clipper circuit. In order to analyze the clamper, they have two major steps, which is we need to analyze for the forward and reverse condition. So for the first step is the forward. During we analyze the forward conditions, what the step we need. So here I list the step what we need to do during analyze of the forward. So the first thing is to identify the forward direction. So where the forward direction either is at the positive cycle or at the negative cycle. Then the second step is this to analyze the forward circuit. For the third step is we need to identify or to calculate the value of the VC. So here VC is equal to what? So at this time, we need to use KVL at the inner loop, which is this inner loop is refer loop at the diode during the diode is an on condition. In order to get this VC, we need to set the polarity of the VC, which is it must follow the direction of the current polarity. And after we set the polarity, we must maintain the polarity. Means that we cannot change the polarity until the end of this analysis. After we get the value of the VC, the next step is we must calculate the value of the VR. And the last is we need to plot the graph. For the next step is we need to identify for the reverse condition. So again, the first step for the reverse condition is we identify the direction either at the positive cycle or at the negative cycle. Then for the second step is we need to find out the value of this VC. At here, we can say that VC is at the reverse condition is equal to VC during the forward condition. This is because during the forward condition, our capacitor is fully charged. And when the reverse condition, our capacitor is stopped charging and it achieves the full limits of the voltage for the capacitor. So that's why we say that VC during the reverse is equal to the VC during the forward condition. For the third step, we need to find out the VR again. And lastly, we plot the graph. Next, after we calculate the VR for the positive cycle of forward condition and reverse condition, and we already plot it at the graph. So how are we going to check our answer? Either it's correct or not. So the tips is by checking the total swing, where the total swing of the input is equal to the total swing of the output. So what is the total swing? Swing meaning that for the input is a addition of this part and this part. And the swing for the output is this one. So here we call it the total swing of the output. So if we get the same value for both input and output, at here we have 1V for example, and here we have another 1V, and here we have 1V. So the total is equal to to V. So then we check with our output here. Again, this is same value. So this meaning that our answer is correct.